All right, now problem set 2, problem 6. Now we've got this, well, what is it? Is it a line? Remember, lines had x's and y's and maybe a constant, but we got an x squared here. So this is most certainly not a line, and this is going to be what turns out to be called a parabola. And if you have an x squared term, and now this isn't quite the same definition of or that we've been using, but if you have an x squared or a y squared, but not both, that's when it's going to be a parabola. So notice here we have an x squared, but just a y. So that's how you know when you have a parabola, when there's just one of the x or y are squared, but exclusively or, not both of them squared. So this is what you do when you examine a new function. We consider what we call the limiting behavior of this equation. Now, by limit we mean what happens when x gets really big or really small. So that's question A. So as x gets really big, what does big mean? Like say x is 1,000,000. What's y? Well, y is 1,000,000 squared. Oh my, that's a huge number. Right? Say x is 1,000,000,000 or 1,000,000,000,000. What happens to y? Y would be 1,000,000,000 squared or 1,000,000,000,000 squared, right? These are huge numbers, right? So as x gets bigger and bigger and bigger, y is getting even bigger, right? So if you were to freehand this on an axis, we don't have too much information yet, but we know as x gets really big, y is going to get really big too. And so it would seem that the curve is going to approach infinity in both the positive x and the positive y direction. And so it's going to end up going kind of something like that. But there's two limits, right? There's x equals positive infinity way at the right end. You can think of like x equals negative infinity way over here at the left end. So the limiting behavior is what happens for these extreme values of x. Really, really big x, really, really small x. And so as x goes to negative infinity, right, you're coming out here way to the left. What's y? Okay, let's say x is a huge negative number like negative 1,000,000. Y would be negative 1,000,000 squared. Negative 1,000,000 times negative 1,000,000. And when you square a number, right, negative times negative is positive. Notice that for really negative x values, you're getting big positive y values. Like if x were negative 1,000,000,000, y would be positive 1,000,000,000 squared, right? So really negative x's, as x approaches negative infinity, y is going to be approaching positive infinity. And so we see that this curve is going to be going up and left, all the way to the left. It's going to be going up and right, all the way to the right. And like I said, it's not a line. It seems like this is maybe more of a curve that's going to kind of turn itself around somehow. Now, notice part B. Can y ever be negative? Y is x squared. If you square a positive number, if you square a negative number, it's never going to happen that y can be negative. So I'm going to kind of cross out the negative part of the y-axis. We know that the function isn't going to be able to, quote, live down there. And maybe it wasn't on here, but, you know, always try the point 0, 0. mostly because it's easy, right? So if x is 0, 0 squared is y, and we see that that point 0, 0 is on the line, right? There's no negative y's, all positive y's. And you can go ahead and plot this one with the computer. I'm going to show you in the next exercise. I'm not going to show you here. If you want, you can pause for a second before I give away the punchline, and you'll see that this curve is going to be a parabola, as we call it, that kind of turns around with an inflection point here at this point 0, 0. So part D, we'll do this in a moment. What do you think x equals y squared can be? Remember our trick with flipping it around the 45-degree line, around that line, y equals x. Can you maybe get a picture in your mind's eye before we go back to the computer here in just a moment?